Hello, Matt here from chemistrystudent.com. In this video, we're going to look at percentage yields and how to calculate them. We're going to talk about what percentage yield is and how to calculate it using given data. Before we talk in detail about percentage yield, it's essential you are comfortable with the idea of the mole. The mole, as well as other mole-based calculations, have been covered in separate videos. Check the links in the description below. The percentage yield of a reaction is a way of comparing how much of a product has been formed and obtained in a reaction compared to how much of the product that could have been formed. In reactions, there is a theoretical maximum amount of product that can be formed, and this is based on the moles of reactants that are reacting together. I say theoretical there, as a set of reactants will never perfectly react together to give the maximum amount of product that they could. Some reactants may leave the reaction mixture before they get a chance to react. Others may react to give slightly different products, and sometimes products formed will leave the reaction mixture before being collected. Reversible reactions can also result in lower than expected product amounts. In a reaction, the amount of product that gets formed is called the yield. The maximum yield that could be produced based on the moles of reactants that are reacting is called the theoretical yield. The amount of product that does get produced in reality is called the actual yield. A percentage yield is a comparison of the two and equals an actual yield obtained divided by the theoretical yield that could have been obtained, multiplied by 100. Percentage yields are based on experimental data and can only be calculated after a reaction has happened and the amount of product formed measured. For example, oxygen reacts with hydrogen to form water in the reaction shown. If 4 grams worth of hydrogen reacts completely with oxygen, the maximum mass of water that can be produced is 36 grams. This is because there are 2 moles worth of hydrogen reacting. Moles equals mass divided by mR, with the mR of hydrogen being 2. 4 divided by 2 equals 2. This means if 2 moles of hydrogen reacts completely with oxygen, 2 moles worth of water will also be produced, as the balanced equation shows us the molar ratio of hydrogen to water is 2 to 2. 2 moles of water would have a mass of 36 grams. Mass equals moles times mR, with the mR of water being 18. 2 times 18 equals 36. Now, this 36 grams of water is the theoretical mass that could be formed, the absolute maximum possible if all the hydrogen and oxygen react perfectly together. If, when the reaction was actually carried out, only 29 grams of water was produced, the percentage yield would be the actual yield, 29 grams, divided by the theoretical yield, 36 grams, times by 100. This would give 80.6%. This means 80.6% of the maximum amount of product possible was obtained. The higher the percentage yield for a given reaction or process, the less wastage there is and the more efficient it is. So, to summarize, percentage yield is a way of showing how much of a given product was formed in a reaction compared to how much could have theoretically been formed. Reactants will never react perfectly together to give the theoretical maximum amount of product possible. Some reactants may leave the reaction mixture before they get a chance to react, others may react to give a slightly different product, and sometimes products formed will leave the reaction mixture before being collected. Reversible reactions can also result in lower than expected product amounts. In a reaction, the amount of product that gets formed is called the yield. The yield that could be produced based on the moles of reactants reacting is called the theoretical yield, and the yield that is produced in a reaction is called the actual yield. Percentage yield equals actual yield divided by theoretical yield multiplied by 100. A high percentage yield means less wastage and a more efficient reaction process. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.